Yeah, we start with sequencing chapter. Of course, I told already about when you have a single machine and when you have multiple jobs, you can use SPT rule. Okay, SPT rule for sequencing the jobs. And normally, even in a CI point of view and SWE point of view, we're going to give two jobs and two machines n jobs only, or three machines n jobs, or two jobs n machines only. Okay, so these three only. So here I start with the first type. So before I want to give introduction about the sequencing. When a number of jobs are given to be done and they require processing on two or more machines, the main concern of a manager is to find the order or sequence to perform these jobs. Okay, normally this is the main problem a manager faces. So for example, they may have only two machines or three machines, and they have multiple number of jobs, n jobs. Then normally the problem for any manager is how to order them. That is how to sequence them to perform. Okay, that's the main problem normally the manager they're going to face in the organization. We shall consider the sequencing problems in respect of the jobs to be performed in a factory and study the method of their solution. Now I'm going to take one problems along with how they're going to solve. This is about how we want to take the timings of processing of each of the n jobs on each of the k machines in a certain given order may be given. Okay, what is given in the problem? So you are going to get the processing time, that is the timings of processing of each n jobs. You may have multiple number of jobs, say 5 jobs, or 10 jobs, or 20 jobs. Likewise, you may have multiple number of jobs. So we are going to give you the processing time of each job. How much time each job is going to consume to get it ready. That is converting the converting the raw material into finished product. It's called as the processing time. So processing time is given, and also number of jobs also given, number of is also given. In the given order, remember very important here, what order given also very important. Say for example, you may have two machines, A and B. Then order may be given that A, B, you have to sequence job on A, B order only. That is A machine first, then machine B. Sometimes they are going to give in the order of BA also. That is first you have to assign the jobs on B machine, then on A machine likewise. So you have to make sure that what order is given. If order is not given, then you can take by default A, B only. If it is a 2K, two machines case. If it is three machine case, then A, B, C by default. And the time for performing the jobs will be measure of the effectiveness. Now you have to find out the total processing time of all. That's called as the total elapsed time. Nothing but the processing time at idle time of the machines. So for example, when you're going to assign the job for machine A, machine B become idle. Then when you're going to calculate the total time spent by a job is equals to the processing time plus the idle time the job spent with the machine also, or you can say sometimes machine also going to become idle also. So you have to find out the total elapsed time. We shall select the sequences for each for which the total time taken in processing all the jobs on the machine would be minimum. So basically we are trying to focus to minimize the total processing time. Okay, that's what the objective job. Remember here, what is given here? Processing time is given, number of jobs are given, number of machines given, and you should know the order now, sequence, and you have to find out the total processing time. Okay. Now, in this unit, we shall look into the solution of a sequencing problem. N jobs, two machines. Say, for example, A and B, two machines given. All jobs are processed in the order A, B. Okay, it is given A, B sequence. Means you have to sequence the jobs in the order of A first, then B. Okay, A, B. Second, N jobs and three machines. So, for example, you may have multiple number of jobs or more here, N jobs, and you may have three machines, A, B, and C. All jobs processed in the order A, B, C. I told that if sequencing is not given, then you have to take by default A, B, C only. Sometimes in the question paper, they may go on to give the order of BAC or CAB also, or even BA also. Problems with two jobs and n machines. Sometimes you may have only two jobs, but you have multiple number of machines. So here you have to make sure that machines idle time should be as far as possible minimum only. you are trying to minimize the idle time of machines. Anyway, because processing time is remain same, but you are going to focus on minimizing the idle time. Okay, so that is basically we are going to use a graphical solution for two jobs M machines problem. Okay, so these three we are going to take in unit number 4, that is n jobs 2 machines, n jobs 3 machines, and the 2 jobs M machines. Okay, I'm audible and going okay now? Anybody can
Yes,
unmute?
sir.
Yes, okay, done. Yes, now we'll start the problem. Okay. Yeah. Now I'm going to take one problem. Processing of n jobs through 2 machines. You please take down on your notebook processing of n jobs on n through 2 machines. N jobs 2 machines. You please take down this one in your notebook processing of n jobs through 2 machines. The simplest possible sequencing problem is of n job 2 machine sequencing problem, in which we want to determine the sequence in which n job should be processed through 2 machines so as to minimize the total elapsed time t. Okay, what do you mean by total elapsed time? Total elapsed time is equals to the processing time of all the jobs plus the idle time of all jobs. Okay, so let's say that we want to use the total elapsed time. Only two machines A and B are involved. Each job is processed in the order A B. Okay, so this is what the problem given. Okay, so straight away we take a problem. Remember here sequencing. What the procedure we're going to adopt is Johnson's rule here. Okay, Johnson's rule. Like in the game theory, I told that dominance rule. And so here, sequencing, what are the procedure we're going to adopt to find the total elapsed time and all? It's the Johnson's rule. You please take down the problem now. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 jobs. It is A, B up to I are number of jobs. P and Q are two machines. This is a two machines n job problem where the time given here, the processing time. So P machine A job takes 2 minutes on machine P. Similarly, job B takes 5 minutes of processing time on P machine. So, for example, B job takes 8 minutes on processing on machine Q. Likewise, these P and Q are machines. A to I are number of jobs. You can write 1, 2, 3, 4 up to 9 also. These are all the processing times in minutes. 2, 5, 4, 9, 6, 8, 7, 5, 4, 6, 8, 7, 4, 3, 9, 3, 8, 11. These are the processing time given here. A to I are jobs, P and Q are machines. So this is the two machines, n jobs, processing time given. Find the sequence that minimizes the total elapsed time. Also calculate the total idle time for the machines in this period. The order given here, PQ, means you have to process all the jobs in the order of PQ only. You please take down this problem now and let me know of taking problem. I'm not in a hurry to complete. Remember, you have to take your own time. You please make sure at understanding the problem.
Sir, we have to note down
Yeah,
the problem
yeah,
just from
yeah.
the previous slide.
No, this much only. It's a problem given. It's a problem. Okay, it's a problem. You have two
So
machines.
only the table.
Yeah, only table. This you can say it's a problem now.
Yes.
Problem given PQ machines, A to I jobs, and these are the processing time. You have to make this table now, and it's a problem given. Find the sequence that minimize the total elapsed time. Also calculate the total idle time for the machines in the period. The order given is PQ order. You take this problem first.
Done, sir.
Done now. Hope all of the students have taken this problem. It's a two machines n job problem, and you have to find out the total elapsed time and also idle time of the machines. You have to find out how much idle time of machine A, P, and machine Q, and the order given is PQ. It's a problem. Now you have to make the order PQ. Write down the order PQ now. Okay. Say here from this side you want to use P. From this side you are going to write P. This time you are going to write Q. Remember here P from here, Q from here. Make sure just make your 9 blocks here. 1, 2, 3, 4, 5, 6, 7, 8, 9. You make 9 blocks because you have 9 jobs. And the order is PQ. So from this side P, this side Q. You write down please. I'm unable to write here because of the I don't know. I'm unable to draw arrow mark and all. Okay, some problem. Next week onwards, I'm going to take the smart boards given by the college. So till then, just take down right now. From this side P, this same Q. You take only 9 blocks here because you have 9 jobs. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't write A, B, C, D and all. Just make the 9 blocks, one box here. If from this side write P, this side write Q. Okay. You make 9 blocks. Don't fill A, I, C and all. Just make 9 blocks. From this side P, this side Q. Here Q, here P. Done. Done. Okay.
Yes, sir.
Yeah. Now, see here, I told that the left side, from left side P, right side Q. You check out here which job can be assigned on which machine. See here 2, 5, 4 and all. Okay, you have that minimum processing time is 2 now. Minimum processing 2. You can assign for P. Means A job can be assigned to P. That's why because 2 is there. See, remember among all the processing time of all, minimum is 2. That's why you are going to write A here. Because this is the minimum processing time from P. I told you from here P, from this side Q. So A is going to be allotted assigned here. Okay, A because processing time is 2 for P. So job A done first. Done. Next. Check out the next processing time. Anywhere you have got 2 here, nothing. Now you are going to have 3 there, 3. But the 3 job G, you have got a 3, but on Q. Okay, so job G processing time is 3 minutes on machine Q. So from here, here G first from Q. For Q, G first. Remember here from this side P, this side Q. So you're going to assign the job G on Q because the processing time is 3 minutes. This side Q, this side P. Okay. Next. Now we can check out anywhere 3 is there anywhere. Yeah, one more 3 is here. Sorry, one more 3 is also there here. That is, you have 2 3s are there. One E and one G. So both on Q. Now you can say here E here. Or you can write E here also, G here also. No problem. Remember, E and G can be interchanged because both are having the processing time on Q. So you can write G here or E here or EG here, here. No problem. Okay, now E and G assigned from Q because the processing time is same, 3. Next, 3, okay. Now 4 is there. 4 is D machine 4, whereas I job 4 minutes. But I job on P and whereas D job on Q. So now you have to assign I job on P. Okay. So now I job on P now. I job on P and D job on Q. For Q, you're going to assign D because the processing time is 4. Whereas I also have got processing time 4, but for P machine. So now you have assigned A, I, D, E, G. Why A? Because P machines 2 minutes. whereas G and E has got 3 minutes. So from this side Q, and I 4 minutes on P, D 4 minutes on Q. So for P assigned I, for Q assigned D. Now you have assigned A, I, D, E, G. Now, 4, I think, yeah, one more 4 is there here. Sorry, one more 4, I didn't see. One more 4 is there. That is C is there. That's a P. Now you can say here C. Remember, I and C can be interchanged. You can write C here, you can write I also, because both are having the same processing time. So from, because this has a 4, this has 4, you can write C, I also interchange. CI or IC. Now total you have AIC, DEF assigned. So now 4 got over now. Remaining just 5. 5H, that is on P. Whereas B also got 5 now. Okay, on P. Now from P you are assigned from B and H. You know, B and H. First B, then H from P side. And only one remaining F, you can assign it. That's it. That's how we're going to make the sequencing of the jobs. Remember, this is not necessarily same sequence. I and C having the same timing. You can interchange C here, I here, and BH has got 4 minutes. You can interchange here and here. Whereas EG has got 3 minutes. You can interchange G here and E here. No problem. So, but ultimately you can have that proper sequencing. So A, I, C, B, H, F, B, D is the sequencing jobs on PQ order. Anybody got doubt here? Can ask me. Anybody got doubt here? Can ask me. Want I repeat also. Okay now. Shall I go ahead now? Shall I proceed, or you want me to explain once again?
Yes, sir.
Shall I go ahead?
Proceed, sir.
Yes. So you know how many are there? 26 only out of 55, 60 students. Very bad attendance. Anyway, that's up to them. I can't do anything. Okay, now sequencing done. Remember, this order not necessarily same order. I told you already. A, I, it can be C, I, it can be H, B. It F is going to be same only. D, E, G, I can G here, A, because of the same timings. Now, you please take down the table. Don't write anything. You just make a table. So job sequence, all 9 blocks here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make 9 rows here. Machine P, machine Q, time in, time out, time in, time out. Idle time for machine Q. You dispatch right now. Don't enter the values. You please make a table. Job sequence. You have 9 rows because 9 jobs are there totally. So there should be C, I think. Yeah, I see BHF, DEG. Right on the job sequence, 9 jobs, 9 rows. You have 2 machines, machine P and machine Q. Time in, time out. Machine Q, time in, time out. And make one more column, last column, to find the idle time for Q only, not P. Because P is the beginning machine, Q second machine in the order of PQ. So you are finding the idle time for only machine Q. Machine P, I'll let you know how it comes later. Okay, done. Shall I go ahead now? Have you taken this table?
Sir, yes, sir. We have taken the table and the job sequence.
Yeah, you write Java sequence, correct. You write all A, I, C, B, H, F, T, E, G. This sequence right. Okay. So now keep that, just open the table. Okay. So for machine B, job A, 0 time it enters. Time in means it's beginning, 0 time in. Time out 2 minutes because the 2 minutes of processing time, 2 minutes. Whereas machine Q, job is going to process the machine Q only after processing on machine P. So it's going to be time in for machine Q because job A is going to be processed on machine P by taking 2 minutes of processing time. So for machine Q, it becomes a 2 minutes time in. Okay. And whereas job A has got how much time? Here, job A has got 6 hours processing time. Okay. So that's why 2 plus 6, 8. Okay. Machine P, job has got 2 minutes of processing time. So after completing 2 minutes of processing on machine P, you're going to enter on machine Q. That's why time in is 2 minutes for Q. It takes 6 minutes for processing time. So 8. Okay. So the idle time for machine Q is 2 because machine Q is going to wait for 2 minutes till the job comes to here. So 2 minutes become idle time for machine Q. Understood? Time in 0 in the beginning, 2 minutes processing time, time out. Machine Q, after completing the processing on machine P, going to come here. So time in 2. And it takes 6 minutes of processing time, time out 8. So idle time for Q is 2 because it's going to wait for 2 minutes. Second job I. So here time in this 2, time in 2. I takes 4 minutes of processing time. So time out 6. 2 minutes time in, 4 minutes is the processing time 6. Okay, but I is ready now. Job is ready, but machine Q is free only after 8 minutes. Okay, 8 minute time out, 8 minutes time in. So it takes I job how many? Here, I job 11 minutes processing time. So 11, 8 plus 7, 19. So machine Q is not going to wait. Timeout is 2. Immediately job I comes here. So 8 and 8, 0. So no idle time for machine Q. Similarly, come to job sequence C here. Time out is 6. Immediately comes here 6. Whereas processing time of C is 4. So 6 plus 4, 10. So C job is processed on machine P and ready for machine Q, but whereas machine Q is free only of 19 minutes. So time in 19, time out plus 7 minutes. Okay, that is 7 minutes G. So 19 plus 7, 26. So machine Q won't wait. 19 minus 19, 0. Likewise, you do for all the jobs. Just ask me if you have doubts. Finished? Anybody got a doubt here? Want me to explain once again? Have you finished? Anybody want me to explain? Okay, I'll start from here. Okay, you understood the sequencing, Rahul? Have you understood sequencing? This one, Rahul Jamkandi. Have you understood this one? Have you understood sequencing?
Sir, he's typing, sir. He said yes.
Oh, okay. Right. I didn't see it. Okay. Now I'm going to start with this table. Okay. Job sequence. You write down the job sequence. What you found out. A, I, C, B, H, F, D, E, G. Remember, this can be as per your suite. Maybe you change also because processing time is same for two machines. It can be A, C, I, and B, H, or H, B, or F, D, and E, G, or G, E, or G, E can be. Okay, so this is based upon the sequencing done. Now you have machine P, machine Q. You have to find out the idle time for machine Q. So now you have machine PQ order. Okay, so see job A, time in means start processing on machine P with 0 time in. It takes 2 minutes of processing time. Okay, see A takes 2 minutes of processing time. So time out is 2 minutes. 2 minutes. Machine Q now, machine Q. I'm talking about only job A now. Job A, it has spent 2 minutes on machine P, means processing time, and then this job is going to machine Q after 2 minutes. So for machine Q, time in become 2 minutes. It takes 6 minutes to complete. Here, 6 minutes to complete processing time on Q. So what happens here? 2 plus 6, 8. It's a timeout of job. I'm talking only about job A now. Only job A. Job A is going to be assigned to machine P at 0 time. It takes 2 minutes per processing time. Time in 0, time out 2. So same job is going to machine Q. So after processing on machine P, it goes to machine Q. So time in 2, whereas processing time 6. So 2 plus 6, 8. Now the idle time for Q, because remember Q is going to wait till the job A comes here. So 2 minutes going to wait. That's why 2 minutes becomes the idle time for Q. Now job I. So job will now after completing A job, now we take job I as per the sequence, because the sequence is I now. So now job I, time in for machine P 2, because 2 minutes it was given for A. Now time in 2. So job I takes 4 minutes here. Job I takes 4 minutes on P, okay, and 11 minutes on Q. So now I'm going to say here 2 minutes in time plus 4 processing time. 2 plus 4, 6 minutes time out. Time in 2 minutes, processing time add ಮಾಡಿದ್ರೆ you're going to get the time out 6 minutes. This is about machine P. What happens here? Machine P, job I was already processed, but machine Q is free only after 8 minutes. So time in 8 minutes for machine Q. So it takes 11 minutes to complete job I. So 8 plus 11, 19. Whereas the machine Q is not going to wait here. So 0 idle time, because time out 8, time in 8, 8 minus 8 0. So you're going to get idle time of 0. Now coming to job C. Now machine P, time out 6. You write this 6 here. So check out here, C job 4 minutes on P, 7 minutes on Q. So now here 4, 6 plus 4, 10 minutes. So job C is free now after 10 minutes, but machine Q is free only after 19 minutes. So this 19 right here, 19 time in plus 7 minutes processing time, 19 plus 7, 26. So because machine Q 19 time out, 19 time in, 19 minus 19, 0 idle time. Now coming to job B now. So time in of 10 minutes is written here. So job B here. Job B takes 5 minutes on Q, 8 on 5 on P, 8 on Q. So now what happens here? Job B 10 plus 5, 15. So it's free. Job B ready now, but the machine Q is going to free only after 26. So this 26 right here, 26 plus 8 minutes on B, 8. So it's right, what happens here? 26 plus 8, 34 become time out. So idle time, 26 minus 26, 0. Similarly, job H, time in 15 plus job H takes 5 on Q, P and 8 on Q. So now 15 plus 5, 20, but here this is 34. So 34 is written here, okay? 34 plus 8 percent time, 42. So idle time 0 because 34 time out, time in 34. So idle time 0. Similarly, F job, time out 20, time in 20. It takes, it's here. F takes 8 minutes on P, 9 minutes on Q. So add madre 20 plus 8, 28. You do 42 time out, right? 42 here, okay? Plus 9 add madkonta 51. So idle time 42 minus 42, 0. Similarly, D job, 28 time out, 28 time in. So just check out here. G job 7 and 3. Okay, 7 and 3. D na D. Okay. D 9 and 4. 9 and 4. So 28 plus 9, 37. So here 51 time out. So write same thing 51 here plus 4 minutes on Q. So 51 plus 4, 55, 0. Similarly, E job, 37 time out, 37 time in, and check out here. So here 7 and 3. Okay, 7 and okay. E job, 6 and 3. Okay, 6 and 3. So 37 plus 6, 43. So time out 55, time in 55 plus 3, 58. So 55, 0. Lastly, G job 43, 7 minutes processing time. So 40 plus 50 and 58 time out, same thing right here, plus 2 minutes processing time on Q. So 58 plus 3, 61. So 58, I think, 3, 61. 61. That's how we're calculating the time in, time out, and the idle time for machine Q. Okay. Let's one more problem. I would solve 1 or 2 problems. Don't worry. Of similar time, kind. Okay, no, Rahul. Others understood? No, others understood. Others understood now.
Yes, sir.
Yes, sir.
Okay. Now here, you want
Yes,
to
sir.
answer here. So, what is the total elapsed time here? 61 minutes. Because totally, to complete all jobs A to G, okay, total elapsed time is 61 minutes. Elapsed time. What is the idle time for machine P? Here, 61 minutes is the total elapsed time, whereas P is free after 50 minutes only. So now 61 minus 50, 11 minutes become the idle time for machine P. 61 is the total elapsed time because all jobs are getting over after 61 minutes. So machine P is getting free after 50 minutes. So it's going to wait till all job gets over. So 61 minus 50 become the idle time for P. Whereas for machine Q, totally 2 plus add all things, you're going to get 2 minutes is the idle time for machine Q. So the answer is the total elapsed time for this proposed sequence starting from job A to completion of job G is 61 hours. Okay, sorry, hours only. During this period, P machine idle for 11 hours. That is from 50 hours to 61 hours waited. And machine Q remains idle for 2 hours only. That is 0 to 1 hour. This is the answer. You please write down this answer at the end. Done? Okay, now finished? All of you finished now?
Sir,
Yeah.
sir, they have asked like find the sequence that minimizes the total time elapsed.
Yeah, by using this sequence, okay, this sequence, you can minimize it. That's it. Suppose you're going to do A, B, C, D and all, this is going to be more. So this is the best sequence in which you have got the minimum total elapsed time. Okay.
So means the first step was that only. We have found the sequence.
Yeah. This one, sequence. This is the
Yes,
sequence
sir.
going to make you to minimize the total elapsed time. Okay, this is the idle time. Basically, this is used to find out the idle time for machine Q and P. Okay, now. Okay, right?
Yes, sir.
Yeah. Done.
Done, sir.
Yes. Now we'll go for n jobs through three machines. Today I'm going to take this problem also. Tomorrow I'm going to solve using that digital board on board. So there I think understand better also. So I'm going to take now n jobs through three machines now. You have three machines A, B, and C. Each job processed on the order A, B, C. Okay. No passing of jobs permitted is same order over each machine is maintained. So for entire sequencing, you have to maintain the same order. You can't skip directly A to C or B to A and something like that. You have to follow the same procedure for entire sequencing. Okay. Our objective will be to find the optimal sequence of jobs which minimize total elapsed time. No general procedure is available so far for obtaining an optimal sequence in each case. Such case, however, the Johnson's procedure can be extended to cover the special cases where either one or both of the following conditions are held. Now you have three machines A, B, and C. So you have to convert this into two machines n job only. To convert these three machines into two machines, so any one condition should be met. That is, the minimum processing time on machine A should be greater than equal to the maximum processing time on machine B. Okay. Or the minimum processing time on machine C should be greater than equal to the maximum processing time on machine B. If any one condition is met, then you can combine A plus B, you make one, and B plus C, you make one. It becomes two machines n job problem. So you have to make sure that any one condition should be met to convert three machines n job problem. You please write down now the heading as three n jobs, three machines. Heading as n jobs, three machines. And the sequence is given ABC sequence. and the condition, any one condition has to be met. One condition. The maximum processing time on machine A should be greater than or equal to the maximum processing time. Remember, minimum processing time of machine A should be greater than or equal to maximum processing time on machine B. Then you can combine A and B and make one machine called G machine. Second, the minimum processing time on machine C should be greater than or equal to machine B processing time. Any one condition should be met. Either minimum of A should be equal to B or minimum should be equal or greater than to B. If any one condition is met, then you can combine A and B and G, you become G machine. C and B, you can make H machine. If the order is given A, B, C only, if it is CAB, then the minimum of C should be equal to maximum of A. And likewise, if you check out here, it is only for ABC sequence only. A minimum should be greater than equal to maximum of B. C minimum should be greater than equal to B. If the order is ABC, if it is CAB, then becomes CA. Okay, CA and BA. If it is CAB. Okay, now the method is to replace the problem by an equivalent problem involving n jobs and two machines. You are replacing now entire, making it as a n job two machines. These two fictitious machines are denoted by G and H, and the corresponding time of Gi and Hi are defined by G is equals to A plus B and H is equal to B plus C. Sorry, I didn't write here H. Okay, H is equals to B plus I, B plus C. Okay, so we are going to get two machines now. G, H. G is equal to A plus B, H is equal to B plus C, because order is given as A, B, C only. If it is CAB, then C plus A becomes G and H is equal to A plus C. Okay. Next. Now, this problem with prescribed order GH is solved by the method which n jobs to two machines. Now, we are going to follow the same procedure of two machines n jobs, because if the condition is going to met, then we are going to follow same of previous one. Remember here, write down these two here. Two fictitious machines are created, G and H. G is equal to A plus B, H is equal to B plus I, where B plus C, sorry, B plus C, and the order is GH. Okay. Now, you take the problem. There are 5 jobs, namely 1, 2, 3, 4, and 5, each of which must go through machines A, B, C in the order A, B, C. Processing time in hours are given below. Find the sequence that minimizes the total elapsed time required to complete the job, and also you have to find the idle time for machine B and C. I forgot right here. There are 5 jobs, namely 1, 2, 3, 4, 5, each of which must go through machines A and B and C in the order ABC. Processing time in hours are given below. And find the sequence. find the sequence that minimizes the total elapsed time required to complete the jobs, and also you have to find the daily time for B and C machines. Now you have 5 jobs, 1, 2, 3, 4, 5, machine A, machine B, machine C. Write down the processing times. They are all processing times. 5, 7, 6 and all processing time. You have to find the sequence that minimizes the total elapsed time required to complete the job and idle time for each machine B and C. Oh, okay, of course, A or C also. Why not only? Okay, take down column. Finished. Have you taken the problem? 5 jobs.
No, sir, still taking, sir.
Yeah. Okay, take it.
Done, sir.
Okay. So this is 3 machines in job. Okay. I told that you have to combine 2 machines and make one G and H. 2 fictitious machines G and H. When the condition met, that is the minimum processing time on A should be greater than or equal to maximum of B, or minimum of C should be greater than or equal to maximum of B. Now check out here. The minimum of processing time on machine A, minimum processing time on machine A is 5. Maximum processing time on machine B is 5. So minimum processing time on machine A is equals to maximum processing time of machine B. So the condition is satisfied. Or else minimum of machine C should be greater than or equal to maximum machine B. But here minimum 3 is there on machine C. condition won't match. But I told that any one condition, either minimum of A should be greater than or equal to maximum of B, or minimum of C should be greater than or equal to maximum of B. So one condition is met, that is the minimum of A is equal to maximum of B. So you can convert this into two machines. So you are going to combine the processing time of machine A and machine B. You are going to make this as a machine G, and you are going to convert, you are going to add machine B, machine C, and you are going to get one more machine H, like this now. Now here minimum of A is equals to 5, B is equals to 5, and C is equal to 3. Since the condition of minimum A should be greater than or equal to maximum B is satisfied, you're going to get all 5 jobs. That is 1, 2, 3, 4, 5 jobs. G is equals to A plus B, H is equal to B plus C. Combine the processing time and prepare one more table. You are just adding the processing time of A and B, and you want to call it as a G, and they are adding the B plus C, and you are going to say it's H. Now you have two machines, G and H. Dinesh, class is now, but class is. I have class. Hello. Done?
Sir, the any one condition should be satisfied, like
Yeah.
minimum of A should be greater than or equal to B, or minimum of C should be greater than or equal to B.
Yeah. Anyone.
Yes, sir.
Anyone. I think it's written here. Or, okay, written here, no? Any one condition. Need to meet. Okay, if you want to write here specifically. Or. Okay, any one condition. Any one condition.
Yes, sir.
Okay, got it now? Done this.
So taking the table, sir.
Yeah, okay.
Done, sir.
Done? Okay, yes. Okay. Okay, now you have to make the 5 jobs block like this. Okay, oh sorry. You make a block now, block of 5 jobs. Likewise. Yeah, you make a five blocks like this, because we have five jobs, 1, 2, 3, 5, and order GH from this side G, this time H. You make like this. You make a box of five, because we have five jobs. Five jobs. You make a five blocks, and this side G, this side H. So now the sequence becomes 2, 5, 4, 3, 1. Check out now. Okay. See here, I told you make a box here. I think tomorrow I'm going to show you. I think I'm getting a digital board today. Afternoon I'm going to practice. Tomorrow morning I'm going to take a digital board. I'm going to show you once again. Don't have to worry. Try to understand here. You're going to make a box of five jobs like previously, and you're going to write a G from this side, H from this side, GH order. So check out here which job is going to be the minimum. So H minimum. Okay, 5. So job 1. So this side you're going to assign job 1. Job 1 for H. Okay. Second, now you have 7 is there. 7. That is sorry, job 1 already got over. 5 is a H side. Next 7 already done. Now remaining 2 is there. 2 is for even G also there, H also there, and even 5 also for G. So what you going to do now? 2 and 5 are going to assign here. Okay, that is 2 and 5. So first job on G and the second 5 job, because both are having the same processing time, 8 and 8. So now 8 job 2 over, job 5 over. Now remaining processing time is that is a 9, that is a 3 on H. So now you can write here, that is a 3 here. So now 1, 3, 2, 5 over, remaining 4 right in the middle. That's it. That's a sequence. You make a box, please. I am unable to do here. A lot of time takes, a lot of time to draw and on. So make a box here and write from this side G, the same H, and write down the sequence 2, 5, 4, 3, 1. Just like previously. The previous one you did the same way. You take the job which is going to consume less time, assign to G, takes time here, assign to H likewise. Anybody got doubt, you can ask me. This one, I don't have block here. So you do just like a previously I did. Okay. You got this one, this sequence. You got the sequence?
Yes, sir.
Yeah. Anybody? Any? Rahul Jamkandi. Sir, can't read your charts while presenting. Unmute and speak. Neeraj Bhaskar, what he said? Unmute and speak. Sir, can't read your charts.
I told him, sir, means while presenting you can't read the chats.
Yeah. Okay.
So I told him to speak.
Okay, yeah, correct. You told him to speak. Good. Yeah, because now I have to shift over from here to there. That's right. Good. Yeah, you
Yes.
have to cooperate. Nice. Right. Okay. Yes. Now, okay, I think you got this sequence right now. Got a sequence. Understand it. Don't have to worry. Tomorrow I'm going to do one second. I'm going to do one more column of same 2 machines, N job, 3 machine N job, on a digital board. Okay. Write
Okay,
down
sir.
the table now. You have job sequence 2, 5, 4, 3, 1. This one 2, 5, 4, 3, 1. You have 3 machines now. You can't write G and H because we have to take the 3 machines problem. So machine A, machine B, machine C. And you write idle time for B, idle time for C. A anyway don't have to worry. Just like a previous problem, what happens? We have taken only machine idle time for Q only because P automatically comes in the later stage. So now you are going to take only idle time for B, and you have 3 machines, machine C, machine B, machine C. You will take down time in, time out, time in, time out, time in, time out. You make this table and let me know afterwards. I'm going to tell you afterwards. You please write down job sequence 2, 5, 4, 3, 1. This one 2, 5, 4, 3, 1. You write 3 machines, machine A, machine B, machine C. time in, time out, time in, time out, time in, time out, and idle time for machine B, idle time for machine C. You write down this table and let you know, then I am going to explain you. Done?
Yes, sir.
Okay, you have job sequence 2, 5, 4, 3, 1, machine A, machine B, machine C, right for B and C. Yes. Start with the job 2 now. Job 2 in 2 minutes, out 7 minutes, because here job 2, no, you have taken 2. Yeah. So in 7 minutes. Okay. So job 2 out 7 minutes, present time. The machine B is going to be in time in 7 minutes. It takes 1 minute. Okay, 1 minute. So that's why you can say 7, 7 plus 1. Yeah, 8, yeah, 8. 7 plus 1, 8 time out. 8. Now for machine C, time in is 8. And it takes 7 minutes processing time. So totally 15. Remember here, you have taken job 2 first on machine A because ABC is the order given. Remember, if it is CAB, then you should write CAB. If it is BAC, then BAC. Accordingly, when is also going to change, remember. So we have to make sure that what sequence the problem given. So, but here we are given the sequence of ABC. That's why you have taken machine A, machine B, machine C. If it is CAB, then machine C, machine A, machine B, like we should take. Accordingly, this is also going to change. Now, for this one, ABC sequence given, you are taking the job 2 because the first sequence is 2 now. So, time machine A, 0 time in, it takes 7 minutes. So, 0 plus 7, 7. Machine B, time in 7, it takes 1 minute. So, 7 plus 1 is 8 time out. Machine C, 8 time in, it takes 7 minutes processing time. 8 plus 7, 15. Now, idle time for machine B, 7, because here machine B is going to wait for 7 minutes because the job 2 is going to enter machine B only after 7 minutes. So, idle time for B is 7 minutes. C. Machine C is going to be in 8. So but the machine is going to wait till 8 minutes. So idle time for machine C is 8 minutes. Very important. If you know first one, remaining you can go on adding it. That's it. 0 time in, processing time 7. So 0 plus 7, 7 minutes. Machine B after 7 minutes comes here. So time in 7, time out 1 minute processing time, 7 plus 1 8. Machine C this 8, time in plus 7 processing time. So 8 plus 7, 15. So idle time for B is here 7 minutes. For C it is 8 minutes. Okay, that's all for job 2. Anybody got doubt, you can ask me now itself. Because other things are go on adding only. Nothing is there in the next steps. Done?
Doing, sir.
Yeah. You can take no. Don't worry about next. Just take down first only. First one. Time in 2, 7. Just take the first one. Second now. You take the second job 5. So job 5. Time in is 7. Okay. So here processing time for job 5 is 537. So 537. So you add here 7 plus 5. Okay, 12. So now 12. Remember here, machine B is free after 8 hours, but job is yet to come. So machine B is going to wait for 4 hours here, because job 5 is going to machine B only after 12 hours. But machine B is free after 8 hours. So not 8 here, you have to write 12 here, because job 5 is finishing after 12. So 12. That's why 8 minus 12 is the 4 hour idle time for machine B. Because machine B is going to wait here for 4 hours. So 12 plus 3, 15. Machine B now. Machine B out 15. It's coming directly 15 here, because yes, 15. So 15 plus 7, 22. So no idle time, because the 15 out, 15 in. So no idle time for C machine here. Remember this very important second step here. Time in 7 minutes. Time out is a 5 minutes processing time. So 7 plus 5, 12. So 12 is a time in for this one here. Okay. And plus 3. Yeah, sorry. Time out is 8, but you want to wait for 4 minutes here. Okay, not like previous one. You want to wait for 12. So it becomes 12 minus 8 for idle time here. Similarly, take the fourth job here. Okay, fourth job. Fourth job is a 956. Okay, 956. So 12 plus 9, 21. Okay, but remember here, machine B 15 out, but machine job is coming after 21 only. So 21 is here. So 21 minus 15, 6 hours becomes the waiting time, idle time for machine B. Okay, so now 21 plus 5, 26. Remember here, machine B 26 free, but machine C 22 free, but you want to wait till job 4 comes here. So 22 plus 4, so 4 is going to wait here. That's why idle time for C is 4. So 26, 22 to become 26 plus minus 22, 4 plus its processing time 6 to become 32. Similarly, third job, time in is 21. Okay, third job is 645. So third job 645, 21 plus 6, 27. So, but it is going to be 26 out, but it's going to wait for job 3. So 27. So idle time become 1 here, and so plus 7 here, 31. So here 31, it is 32 out. So 32 comes here. No idle time. 32 minus 32, 0. So plus 5 processing time, 37. So here 27, add processing time, I won't get 32. But here 31 out, but 32 in here. So 32 minus 31, 1 here. So add processing time to 34 becomes, so 37 out, 37 in here. So add processing time of 3, So you're going to get 40 totally, 0 idle time for C because 37 37. This is how the idle time for machine B and machine C calculated. Okay. Done. This table done now. Take one.
Yes, sir. Done, sir.
Done now. Yeah, I will solve. Don't have to worry. Tomorrow I'm going to solve the similar problem of two machines here and three machines. I'm going to solve it again on digital board. You understand better. Don't have to worry. Now you have to calculate the total processing time. So total processing time, elapsed time is 40. Total elapsed time is 40. Sequencer 25431. Total elapsed time is 40. Okay. Now total elapsed time 40 hours. Idle time for machine A, how much? 40 minus 32 because after 32, you're going to wait for 8 hours. So 40 minus 32, 8 hours idle time for machine A. Machine A, idle time is 40 minus 32, 8 hours idle time. Machine B, so 40 minus 34, 6 hours idle time. See, 34 is become free, but till the job gets over, it want to wait for 6 hours. 6 hours plus, it will add matrix. 7 plus 4, 11, 17, 18, 19, 19 plus 4, 23. 23 hours becomes the idle time of machine B. 40 minus 34, 6 plus idella share add ಮಾಡ್ಕೊಂಡ್ರೆ 23. Machine C, 8 plus 4, 12. That's it. Idle time for machine C is 8 plus 4. So now total idle time to elapsed time is how much? 40 hours. For machine A, 40 minus 32, 8 hours. For machine B, 40 minus 34, 6 hours plus these three, 23. So it becomes C 8 plus 4 only. So this is the answer. This is the answer. Minimum elapsed time is 40 hours. Idle time for machine A is 8 hours. It is 40 minus 32, means the 32 to 40 is going to wait. And idle time for machine B, I think 25 hours. Yeah, add my correct 25 hours. Machine C, 12 hours. 8 plus 4, 12 hours. 12 hours. Yes, 25. Machine B. Done?
Yes, sir. Done.
Graphical solution. Microphone is blocked. Okay. Rahul Jamkar is blocked, not mine. Okay, done. Okay, that's all for today class. So we'll see you tomorrow. If anybody wants to say anything in the chat box, you can message me or you can unmute and tell me.
Sir, the IIT dates are 19th only. So from 19th it will start.
Yeah, yeah, yeah. Higher test 19, 20, 21st. Higher 19 onwards, no? 19
Yes,
to
sir.
24th. But our OR is on 23rd.
Sir, 20th, I think so, sir. 20th.
Second day, 21st, I think.
Yes, sir.
Second day. Because no, I think 19th to first day, they're going to give gap, no? 19, 21st, 23, likewise, right now.
Sir, gap is not there, I think so, sir.
No, what they are given, I think 1 week test there, no? First day, all civil branches, CS, ENC, electrical and all. Second day, civil mechanical, architecture, aeronautical, I think, something like that.
So means still they have not. Yes, sir. 19, 21, 23.
Need to understand, yeah, correct. Okay, 3 days, correct. I think OR comes on 21st.
Yes, sir.
Yeah. So OR, I think I told you already, that is first column OR theory for 4 marks, 8.5 formulation graphical theory. Second question OR theory 4 marks, 8.5 marks simplest problem. Third question, third A, game theory, dominance rule. B, graphical solution. So 6 plus 6.5. You have to answer any 2 questions. Right? Okay. See you tomorrow. Same time. Harsh Pujar.
Thank you, sir.
Harsh Pujar, where are you? Not finding.
Yes, sir. I am present.
Present. Yeah, I'm seeing you. Okay. You please tell others also to attend the class because no war such a subject that you need to attend. Unless you attend, difficult to understand. I think so. You can't study on a row, right now.
Yes, sir.
You have to attend. You tell them at least understand that. I'm see. Remember, this is a S plus subject, S plus grade subject. You can score 100% full marks. I will tell you. I'm guarantee that you are going to get all students can score S plus grade in this subject because others bit like I think switch off the record. Okay.
Yes,
Remember,
sir.
others bit are very it will be difficult. You can't score. Whereas this subject can be around